in this. Okay, let's move on and talk about a different topic. And again, this is all in that publication. Improving natural gas engine efficiency. Always an interesting topic because our natural gas engines are somewhat inefficient at times, and we kind of let them slide. And this is a table that kind of gives you an idea. And what we're looking at is a 75 horsepower motor for the pumping requirements, 400 GPM, 300-foot lift, 20 pounds PSI. And basically how you read this table, here's the natural gas price, 4, 8, parameterized up to 12, to give you an idea what these annual savings are. And we've got the annual savings over this. So if you can get a 2% increase, let's say you're sitting here at the 16 and the $4 natural gas was where we are. If your engine's running at a 16% efficiency, even if you just move that up to 18, we're looking at about a $900 savings, okay, that you will get. And when you think about that and you look over the life, and we assume the life of about 5 years, you'd be getting that 900 from that improved efficiency over 5 years. Basically, we're talking about increasing approximately, what, $4,800 to $4,600. Now, how's that become important? How's this table important then? Okay, well, you can start to get a feel for what you can afford to pay to improve your efficiency. Okay, the other thing I want to point out as you go through this, so if you can drop from 16 to 22, basically is what you're going to get is the 3,200, okay, minus the 600, so you're going to pick up about 2,600 in annual savings. Now, and then you go over to the discounted amount and look at that 22 versus the 16, 14,500 minus the 2,800, that's about, what, 11,700, and that's what you could afford if somebody came to you with an option to increase that efficiency that far. So it kind of gives you the scale. What happens as you increase fuel price? Basically, you can take it from going from 4 to 8, those savings double. Okay? So the reason we put this table in there in particular is to give you a better idea of what that improving that efficiency could be worth to you, okay, if you have questions on your engine. Now here we looked at the 75 horsepower, and again that's about the 300-foot lift. We'll look at the 125 versus 400 foot, and as you'd expect, just moving up 2% in that efficiency. If you're down here at the 16, we'll add another $1,700 in savings per year, or discounted, that savings goes up to approximately $8,000. Okay? So it's to give you that feel for what you could achieve by improving that efficiency. So you can start to look at it and get an analysis on that. And so you think about a lot of things in this publication. It gives you that framework from which you can then go ahead and make that analysis, because one thing we've learned over time is what? Shit happens. It changes, okay? And kind of gives you an idea, though, of what this works out to be. The next question, and the last question that we really looked at, and it comes up a lot, is should I convert to electric? Okay, I get this question about every other month. And so it really is, to convert or not to convert, that is the question. And we did a basic analysis on this, Bridget Guerrero did for me, looking at a 200-foot lift, 500-foot lift, and what the estimated investment cost for the natural gas engines are, approximately $11,000 versus $36,000, okay? 12 years life on those engines, annual maintenance and repair, $1,000, $1,400. Okay, and that gives you the, kind of the dollars per acre per year that you anticipate that you're paying in the lube maintenance and repair. Estimated salvage value 10%. If you went to electric, so you're starting out with a situation that you are natural gas, and the question is, should I go electric? Here's the cost you're looking at. Notice that we are substantially lower on the investment cost for the 200-foot lift in that electric engine versus, and 500-foot lift, $9,000 versus $36,000. You do have those conversion costs, which were estimated in here as $7,500 and $15,000 per year. Notice one of the things, and again, I'm not going to hit this on the summary or conclusions or takeaway points, is that the life on these engines are longer, the repairs and maintenance are less. And that's something to consider with electric, because it's really, you think about it, it's really a whole lot easier to flip a switch and move than it is to mess around with those natural gas engines. Saying that, asked me a year or two ago, and I said, man, you really got to look at electric. When we actually did the analysis, and I'm not going to go through it, this is the discounted savings over 20 years, or discounted costs over 20 years of the electric. This is the discounted costs over 20 years for the natural gas where you started at. And notice that point crosses about $4. This is at a 200-foot lift, okay, and this is what that kind of analysis. Again, things are changing. But, so it's telling you around that $4, it kind of works. It's about an indifference on the 200-foot lift. At the 500-foot lift, natural gas is going to have to be around $5. And actually, when we start looking at some of these other factors, they may increase. And I want you to keep that in mind. So we're talking about $5 being equivalent to about 7 cents on the electric, 7.3, somewhere around there. Kind of gives you an idea where these break-evens are, considering this. Now, so again, lower lifts, I would say looking fairly good. As far as conversion, up here, you just better like the convenience at this point, okay, before you try converting. And it's a really tricky thing to evaluate. Now, first of all, do we expect natural gas prices in this range? Okay, because it gets up there. Remember, it was just what, 2, 3 years ago, 4 years, 5 years? We saw $10, $12 natural gas, right? So, in that case, I was sitting there, man, think about it, electric. It's time to go. Flip the old switch. But the reality is, when you start looking out to what natural gas prices may be doing in the future, you find this. This comes off the Board of Trade, okay? And this is the natural gas price from as of July, for July 12, all the way out to July 22. Notice that we're sitting there at the time I printed this off last Friday at $2.85, okay, which now is like $2.60 something. Notice that it takes to at least, probably 18 before it gets up to 5.30, and even clear out here to 22. It's 6.40 plus your basis, okay? So that decision, if you're especially pumping at that heavier lift, to convert from natural gas to electric is very, very tenuous. You just better provide, like the convenience, maybe you got a labor problem, but there's a lot of things to consider that really I find interesting as you go around the panhandle when you start to look at this decision. This is the electric company. We have a lot of variation on who you are with that will affect that decision, because what it does is you have different rates depending on what electric company, what that energy balance is, how they like dealing with agriculture, peak load charges that weren't factored in. You may have a flip a switch charge. So I'm sure a lot of the companies have that. You flip the switch, and that first time through at least, and you'll get an extra charge. There can be line extension charges, and those can run $10,000 to $15,000 a mile. And basically, if you look at your break even on that, and we did some sensitivity analysis, not included in the publication, it adds about $1 to that, or $1 to that break even MCF. Meter installation charges varies by company. I can't mention companies, but there are some that will charge you $2,000 to $3,000 to put in an electric meter. Others will not. And so you need to factor all these in making that decision. Just don't go, ah, yeah, I like flipping the switch. Think about what this has cost. And on the flip side, you need to think about on the natural gas what that basis is. When I price basis for natural gas in my budgets every year, I use about 50 cents, okay, plus 50. If you are in certain parts of the panhandle, it can be $1 plus. And the reason being is the competition may not be there. Okay? So you need to look at both sides of this equation and not just the general analysis. What this analysis does kind of gives you the framework, plus it gives you an idea of where these break-evens may sit on this thing. Now, in this publication, I'm not going to show you, there are a lot of additional tables that you can get. And again, the estimated gross investment is given for each of the systems and for each of the pumping lifts. The useful life and the salvage value assumptions are given in an appendix. Fixed cost is evaluated for the 5. And then the variable cost for the high water use for each of the lifts and each of the systems. There's a table with, and that's for the high water use, intermediate water use, and low water use on this thing. Okay? So those tables are in the publication. So it came down to it, you know, I started thinking, man, I got so many things to tell you, you know, you got to think of that nice stuff about electric, and you got to think about the costs associated with it. You got to think about the investment costs and all this and that. And then I remembered one of the things, you know, I do a little bit of speaking, and I've been on panels before. And one of the things I picked up from a panel I was on, actually it was about speaking, was from this one speaker, and he cited some literature that in an hour you'll remember 3 to 5 things I say. Well, I got a half hour. So that means that you will maybe remember 2 to 3 things that I say. So I decided to cut it. You know, I had this nice summary and I said, no, bull. I'm going to cut it to 5 points. Hopefully you'll remember 2 of them. And after doing 13 presentations in 2 weeks, I got a little terse on some of this stuff. And I'll keep that in mind here. So furrow irrigate. If you are furrow irrigating, stop it. Yeah, and that's a little bit on the edge. But the reality is, if you can put a pivot on there, you're going to be doing much better. In most cases, and especially if you're growing a high dollar crop, drip will work better than furrow. Okay? So I think you need to consider that. Then under sprinkler irrigation, takeaway message is, how low can you go? Okay? And that's the point. You're sitting in a MESA, even a LISA, you really need to get it to the LIPA type. Okay? It will pay in the long run, whether it be bubble or drag sock or whatever it is. It will pay in that efficiency, and it really would have paid this year. Okay? So if we're looking at drip irrigation, you know, and again, you got certain scenarios that need to be. First of all, it needs to be limited water, okay, which makes sense, given the system, because you've got so much cost in there. Is there yield increases? That's one thing that's not evaluated. You know, if I'm just looking at it from a pure energy standpoint, for the improvement in efficiency, given the cost structure, it won't work, okay, except for furrow. Okay? It won't work. But what you need is yield increases, and some of the yield increases that have been shown can cover that cost. But remember, you got a substantial investment cost, so I'm still holding to the premise that if you're growing high-value crops, whether it be marijuana or cotton, and you know, last year I said you could even justify it maybe on corn. This year with my price outlook, you couldn't. Okay? But the point is, in order to capture that cost, I think it still has to be a relatively high value crop, and you have to get some of these yield increases, which can happen under limited water. And again, also obviously fitting in the oblong type deal. Okay, the last 2 points, improving natural gas energy, you need to, very simply, it's a cost versus return thing. And again, you've got to answer these questions. What is the engine efficiency? How much can it be improved and for what cost? What is the lift? What is the natural gas price you want to evaluate? And then you can just go to that table and that'll give you a good feel whether it's worth improving or not. Okay? And then on the last thing, conversion from natural gas to electric. 200 foot, it's minimum. You gotta be looking at $4 natural gas, and again, that's somewhat of a trade-off with the electric price before it'll work. 500 foot lift, it's gonna be a minimum $5, I'd say almost $6 before that thing starts to pay from an economic standpoint. Right now, that is pretty tough to pencil because natural gas prices are so low. I didn't think I'd ever complain about that, but on this conversion, that's one of the things you do gotta consider, where that natural gas price is relative to the electric. And again, there are just lots of factors you need to be running when you start to look at comparing whether you should switch or not. I was working through that with somebody last week, actually. And I think the final version was he's looking at 4 wells. We're going to convert 1 to electric, see how he likes it. Because with the natural gas prices where they're at, there was no reason to go ahead, push the situation. Okay, again, the economics of irrigation systems. If you want that publication, you can go ahead and download it at the agrilifebookstore.org. Okay, I do have 8 or 9 copies around here that if you want it, you can have it, but that's all I had left at this point. And if you go there, you can download it, print it off, or else you can order it for the paltry price of $5. Okay.